All right, here we are once again diving into Unit 8. This time today we are doing another combo lesson of lessons 6 and 7. Both of these lessons are about what are called histograms, and this is a new kind of a graph that we're going to learn about together today. So before we start that though, in activity 1 of lesson 6, we're going to do a little review of yesterday's lesson all about dot plots. So let's answer these questions quickly about this dot plot. It says, here's a dot plot showing the weights in pounds of 40 dogs at a dog show. Number 1 says, write 2 statistical questions that can be answered using this dot plot. Okay, so remember, statistical, right? We know it's statistical because there's a variety of answers and because we obviously had to measure these dogs' weights in order to get these answers. So we know that there are statistical questions we can ask. So let's figure out what some of them could be. Now there's a whole lot of questions we could ask and the answers would be right here for us. For example, here's one idea. What is the weight? Whoa. Yeah, I can't write today. Of the heaviest dog at the show. Now, in order to know how heavy the heaviest dog was, I would have to weigh all the dogs, wouldn't I? Weighing all the dogs would give us this data, and answering this question, how heavy is the heaviest dog? Well, there it is right there. That dog at 160, maybe 163 pounds happens to be the heaviest dog. So I could answer that statistical question using this data, but it is a statistical question because in order to answer the question, I have to gather this data by measuring the weights. Okay, so that's one idea. I'm going to do one more just to get your minds moving here, and hopefully you can come up with one on your own. Another question I could ask is something like, how many dogs weigh less than 100 pounds at the dog show? So let's write that one down. How many dogs weigh less than 100 pounds at the dog show? Could I answer that with this data? Absolutely. Here's our 100-pound line. So less than 100 pounds would be everybody from here down, right? Could I answer that? Yes, I'd count up the dots. Now, in order to answer that, once again, I have to measure all the dogs. I know there's a variety of answers possible, right? But here's my question, and yes, I can answer that with my data. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 dogs that all weigh less than 100 pounds at the dog show. So again, there's probably 100 more questions you could ask, right? That would be statistical questions that I could answer with this data. So that's a great dot plot. Okay, number 2, it says, what would you consider a typical weight for a dog at this dog show? Now remember, yesterday we talked about this idea of a typical data point or typical value is all about the center, right? So let's look at our data here in our dot plot and see if we can figure out where a good center might be. Again, we want about the same number of dots on one side as on the other of our center. I know we're tempted to say 100 because that's where the peak is. But there's way more dots on this side of 100 than there are on this side. So I think we need to scoot our center down a little bit to maybe down here closer to 100 or maybe even 100 and what is this, 105, 106 pounds. I would say it's about right there, maybe 106 pounds. Whoops, 106 pounds would be a typical weight of a dog. I know there's only one dog that weighs exactly 106 pounds, but that's more of the center of this data, right? So that's the answer to number 2, okay? Moving on here, it says, here's a histogram. Oh, we're now in activity number 2. Here's a histogram that shows some dogs' weights in pounds, okay? Now, what I want to point out on histograms is that these are not the same thing as bar graphs. I know they look a lot like bar graphs, But each bar, as it says right here, it says each bar includes the left end value, but not the right end value. So all the dogs in this bar are somewhere between 60 and 80 pounds. They can weigh 60 pounds, but they're going to be less than 80 pounds because 80 pounds actually belongs to this bar. Does that kind of make sense? So there could be multiple dogs in this bar. In fact, there are 6 dogs in this bar that weigh between 60 and 80 pounds. There are, what is this, about 11 dogs that weigh between 80 and 100 pounds. There are 14 dogs that weigh between 100 and 120 pounds. See how this works? So notice there are no spaces between our bars because there's no spaces between numbers in our scale here, right? So there are no spaces on histograms, and we have a range of values on the bottom of our bars, not just a single value, right? Let's go ahead and use this histogram to answer the questions here in number 1, okay? It says, use the histogram to answer the following questions. Part A, how many dogs weigh at least 100 pounds? Okay, at least 100 pounds. That means 100 pounds or more. Does that make sense? If they're at least 100 pounds, then it's okay to be 100 pounds, but they have to weigh 100 pounds or more. So this bar right here weighs 100 to 120. So all these dogs count. So that's 14 if I go over to my frequency. These dogs would be more than 100, and there are 5 of them. Okay, so I'm going to start my math here. 14 plus 5 plus 140 to 160. Yep, these dogs are more than 100, so there are 3 of those. And then these guys are definitely more than 100, but there's only 1 of those, so plus 1. Okay, so there's my math problem. 14 plus 5 is 19, plus 3 is 22, plus 1 is 23 dogs. Weigh at least 100 pounds. Okay, part B. How many dogs weigh exactly 70 pounds? Do I know the answer to that question? I know that there are 6 dogs between 60 and 80 pounds, but can I answer that one exactly 70 pounds? Do I have enough information in my graph to answer that? We don't have enough information. So when that happens, you just write not enough information to answer. Now, I'll warn you, that doesn't happen all that often, okay? But when it does, then you can write that down. Part C, how many dogs weigh at least 120 and less than 160? Okay, so we want between 120 and 160. So here's 120 all the way up to 160. So we want these 2 bars, don't we? So that's 5 plus 3, or 8. 8 dogs is the answer to part C. Part D, how much does the heaviest dog at the show weigh? Do we have enough information from the histogram to answer that question? All we know is that this one dog weighs somewhere between 160 and 180 pounds. Do we know his exact weight? No, we don't. Not from the histogram. Now, could we go back to the dot plot and answer that question? Yes, because there's the heaviest dog, right? And we know actually from this that he weighs, what, about 163 pounds? But is there any way to know that on this histogram? Darn it. No, not enough information once again. Okay, part E. What would you consider a typical weight for a dog at this dog show? Okay, so again, we're looking for center, right? Now, because these are ranges, we can't say one number, can we? But I think it's pretty fair to say between 100 and 120 pounds. Because not only is that our peak, but it is the center of our data. Probably closer to 100, like what we said before. Before, from our dot plot, we thought it was 106, didn't we? But according to this, I think our center, I think it would be closer to 100, but there's no way of knowing because we don't know from this graph, we don't know where those dots are, do we? So all we can say here is somewhere between 100 and 120 pounds. Right? Because to explain your answer, you could write something, because that's our peak bar, that's our highest bar, and because it is the middle of our data, the middle of our frequencies here would be somewhere in here, wouldn't it? Let's see, this is 6 and this is 11. So there are 17 on this side. There's 9, and then we split this down the middle, right? So we could roughly say that the middle is going to be somewhere in there, can't we? Okay, so however you want to explain that would be fine for number 1, part E. Okay, let's go on to number 2. Discuss with your partner. If you use the dot plot to answer the same 5 questions you just answered, how would your answers be different? Well, that's kind of where I was going with some of these. I couldn't find the exact answer, right? For example, could I have found how many dogs weigh exactly 70 pounds on my dot plot? Yes, I could. I could go to 70 and see that one dog, there he is right there, one dog weighs exactly 70 pounds. So on the dot plot, I could have answered that question. We already talked about this. Could I answer the heaviest dog on the dot plot? Yes, because there he is, right? So in some ways, dot plots are better, aren't they? Okay, so to answer this question, yes, I could have answered some of those that I couldn't have answered with the histogram. But on the flip side of that, was it easier to find the center on the histogram? I think it was actually easier to find the center on the histogram, wasn't it? And it was easy to count up these frequencies, right? So in some ways it's easier and in some ways it's harder. Well, that's why we have 2 different kinds of displays, right? Because sometimes different displays are better for different things, okay? How are the histogram and the dot plot alike? How are they different? Well, I think you can see some of their similarities and some of their differences, right? They show the same data. There are peaks, right? And different things like that. You can find the centers on both. You can find the peaks on both. You can answer a lot of good questions using both. But there are some differences, aren't there? Okay, so you can write down what you discovered on number 2. Okay, let's move on to activity number 3. In activity number 3, oh, look at this dot plot. That's a crazy looking dot plot. Let's read about it. It says every 10 years, the United States conducts a census. In fact, we just did a census this year, didn't we? Which is an effort to count the entire population. The dot plot shows the population from the 2010 census. So this is the last census that was done until this year, right? This year we just did it again. It's done every 10 years, right? So this is the last one we just barely did 10 years ago. For each of the 50 states and the District of Columbia or Washington, D.C. So do we know how many dots are on this plot? Yes, we do, because we know that there's 50 states plus Washington, D.C., so we know there's 51 dots. Now, if you were to look at this graph, can you see 51 dots? Holy cow. I see a problem there. Let's keep reading. Number 1, here are some statistical questions about the population of the 50 states and D.C. How difficult would it be to answer the questions using this dot plot? So what we have here in this activity is a little chart, and I'm actually going to fold this down so that these name lines are not in our way. Okay, so we're going to answer these questions, okay? It says in the middle column, so using the dot plot, you're going to rate each question with E for easy to answer, H for hard to answer, or I for impossible to answer. So just looking at this dot plot, can we answer these questions? Okay, let's look at part A. How many states have populations greater than 15 million? Well, these are populations of states in millions. So if we're looking for 15 million, here's 15 million right here. How many states have populations greater than 15 million? Well, that's pretty easy. 1, 2, 3, 4. That was easy, wasn't it? Okay, let's go on to the next one. Which states have populations greater than 15 million? Wow. We know there are 4 of them, but do we know which states they are? We have no way of knowing yet. It's not only hard, but that is impossible. There is no way to know that. Part C. How many states have populations less than 5 million? Okay, well, 5 million is right here. Uh-oh. Can I count those dots? That's all but impossible, isn't it? I can't even say hard because I have no idea how many dots are in there. They're so close together. Do you see that? Those dots are so close together, there's like no way we're going to be able to count those. So I'm going to say impossible on that one. D. What is the typical state population? Wow. Typical. So I need to find a middle, don't I? A center. If I don't even know how many dots, I mean, I know there's a lot of dots because it's practically a solid line, right? But do I know where the center of those dots are? I don't think I can do that with a dot plot, right? So what is the typical state population? Well, I know it's somewhere in here, right? I would say that's hard. I don't know that it's impossible. I could probably say maybe 5 million, maybe 4.5 million, somewhere in there would be the middle, because we know there's a lot of dots here and here, right? Even with the few that are out here, there's still a ton. It's hard, but it's not impossible. That's what I'm going with. E. Are there more states with fewer than 5 million people or more states with between 5 and 10 million people? Okay, so are there fewer than 5 or are there more between 5 and 10? So which group here is got more people in it? More states in it, I mean. Well, I think that's pretty easy to see because of all these gaps here, right? There's like no gaps in these data points. I think there's more dots here than here. Do you agree with me? So while this is kind of hard to tell, it's not impossible. So I'm going to call that one hard, but not impossible. Okay? Because really, do we know the number of dots? No. So we can't say it's easy. But I think it's hard, not impossible. Last one. How would you describe the distribution of the state populations? In other words, how varied is that data? Well, that's kind of hard to tell. Well, is it hard to tell? No. We got a big old clump of data down here, don't we? So I don't know that that's terribly hard. I'm going to actually call that easy, because most of it is all right there, isn't it? So I think we can describe it pretty easily. Most of the data is going to be between 1 million and 7 million, right? So I think that's pretty easy, okay? Now, as you can see, later on, we're going to come back and use a histogram. And we're going to see if these same questions are easier or harder using a histogram. But we're going to not worry about that quite yet because we've got to make the histogram first, okay? Our data for this next problem, I'm not going to get papers out of my way. Our data for this next part of this activity is all right here. Now, this is all 50 states and DC, District of Columbia. That's Washington, DC. So there are 51 data points here. Here are the exact answers, okay? We need to first make a frequency table of this data, and then we are going to make a histogram of this data. Now, this is going to take a few minutes. So what I'm going to do is I'm going to have you go away for a moment and do the frequency table. We've done this several times. So go and do the frequency table, and then I'll do the same thing, and I'll show you the answers in just a bit. Okay? and then we will make the histogram together. Is that a fair share? Okay, so go away right now, or pause the video or whatever for just a second. Go and do your own frequency table just to practice, and then we'll check our answers in a second. Okay, here we go. Alrighty, I just finished my frequency table. I hope you did too. Here's what I got. Now, there were a lot of states between 0 and 5 million, and I think we could tell that from that dot plot, couldn't we? So my tallies actually went outside the box, right? But that's okay. So this is what my tallies looked like. Let's put some actual numbers in here. 5, 10, 15, 20, 25, 26, 27, 28, 29 for that one. 5, 10, 15, 16 for that one. 2, 2, 0, 1, 0, and 1. So there's my answers, my frequencies for my table. How did you do? I hope we got the same answers. I was super careful. I hope you were too. Okay? Now that we have our frequency table, it is now time to turn that frequency table into a histogram. Once again, I'm going to get this name line out of the way here. I'm folding down my paper. There we go. So now it's time to make a histogram, and here's how this works. We're going to make our bars according to these frequencies, right? I got to make sure we're all on screen here. Hopefully we can see everything we need to see. Let's see, I'm not quite seeing everything, am I? Can I still see up here? I can go a little bit higher, can't I? Can I still see down here? Nope, not quite. Well, we'll deal with that when we get down there. I'll scoot this up for now. Okay, so from 0 to 5, okay, so here's our 0 to 5 population, right? So that's where our first bar is going to go. We have a frequency of 29, so we have to make it 29 units tall. So we're going to go all the way up to here and make our first bar. Okay. Be super careful as you're doing this. Make it nice and neat, nice straight lines. The grid lines help, don't they? And then I'm not going to shade in the whole thing. You can, but I'm just going to kind of semi-shade it in. Okay, so there's my first bar. My second bar is going from 5 to 10, right? And I have 16 as my frequency. So again, on my frequency side, I find 16, and that's how tall this next bar is going to be. Oh, nice and straight lines. Make those lines nice and thick so we can see them. And then fill in that bar a little bit. Okay, so there's our second one. Now, from 10 to 15, we have a frequency of 2. So this is a short little guy of just 2. So there's that bar, and I'll again shade that one in. Moving along, I now have 15 to 20 also has a frequency of 2. So that bar is exactly the same. We'll shade that guy in. Okay. Our next one from 0 to 25 is actually 0. So we don't make a bar for that one. We leave that blank, okay? 25 to 30 though, we have 1. So this is gonna be a bar that is only 1 frequency tall. Okay, we'll fill that guy in a little bit. Then from 30 to 35, we again have 0. So this is gonna be a big gap is what that's called, okay? And then from 35 to 40, we have another 1. So there's our 1 from 35 to 40. So there's our histogram, ladies and gentlemen. Wow, that's kind of a nice looking histogram. Okay? All right. Now, in question number 4, it says return to the statistical questions at the beginning of activity. Which ones are now easier to answer? What it's talking about is going back to this, right? Now that we have our histogram, can we answer these questions easier, harder, or impossible? So let's look at these and see what we think now. Okay, let's look at the first one. How many states have populations greater than 15 million? Well, here's our 15 million. We have 1, 2, 3, 4. That was just as easy as last time, wasn't it? Remember how last time we just counted 1, 2, 3, 4 dots? Well, 1, 2, 3, 4, just as easy, right? So that one is just as easy. How about part B? Which states have populations greater than 15 million? Well, we know there are 4 of them again, but does this help us know which ones? Nope. So that is still impossible, even with a histogram. But that's okay. Moving on. How many states have populations less than 5 million? This is no longer impossible, is it? How many states have less than 5 million? So that's this bar right here. How many were there? 29. That is now easy. It went from impossible on the dot plot to now easy. How great is that? What is the typical state population? Well, now look how easy that is. Remember before on the histogram it was kind of hard to tell, but look how easy it is now. It is definitely somewhere between 0 and 5 million, right? There is no doubt. In fact, is it going to be between 5 and 10? I don't think so. I think it's going to be up here because look how many there are on this side, 29, where there's only 16, 17, 18, 19, 20, 21, 22 on this side. So it's going to be somewhere in here, isn't it? So that is now easy to decide, isn't it? Wow, we went from hard to easy on that one. Part E, are there more states with fewer than 5 million or more states with between 5 and 10? Wow, look how easy it is to tell here. Fewer than 5, 29. Between 5 and 10, 16. Easy, easy. While it was hard before, look how easy that is now. Right? Awesome. Last question. How would you describe the distribution of the state populations? Well, it was easy on the dot plot, and I still think it's easy on this one. Look where the distribution shows all the states, right? So I think that is still easy to see, isn't it? Look how great that difference is. Look how different. Where did our dot plot go? I lost our dot plot. Oh. No, that's not it. That's another dot plot. Oh, here it is. Here's our dot plot. Look how different those displays are. Isn't that funny how different that is? And how much easier. Look how many easies we had this time. So people give histograms a bad rap, right? They think dot plots are so great. But can you do everything with dot plots? Absolutely not. Look how impossible and hard things were that became easy on a histogram, okay? So histograms are actually pretty darn awesome, okay? That is activity 3. We are done with that. Now, I get lost in my place. Where is my next page? Oh, activity 3 is the end of the lesson. Guess what our next page is? Lesson summary. So we are done with lesson 6 and ready to move on now to lesson 7. Before we do that though, please read through the summary. This is a really great summary. And that glossary definition of what a histogram is a super great one as well if you want to look it up in the glossary. On your homework for lesson 6, you are doing problems 1, 2, and 3. Okay, so 1, 2, and 3 only. Do not worry about doing problem number 4. That's from an activity or a lesson that we skipped. So you won't even know how to do that one. So skip number 4. Numbers 1, 2, and 3 are all you are doing on lesson 6 is homework. But now we are doing lesson 7 because again, this is a combo lesson. So let me grab lesson 7's papers. We'll come back to the homework in a little bit, okay? Trying to clear away all this stuff. Now in lesson number 7, we are skipping activity number 1. So put a big X through activity number 1. We're not going to take the time to do that one. We got other more important stuff to worry about, like earthworms. We got to talk about earthworms here, okay? Activity number 2, it says, an earthworm farmer set up several containers of a certain species of earthworms so that he could learn about their lengths. The lengths of the earthworms provide information about their ages. The farmer measured the length of 25 earthworms in one of his containers. Each length was measured in millimeters. Now that's important to understand. These are in millimeters, okay? There's a nice, juicy, long earthworm. Look at that guy. Wow. Okay, let's see what we have to do now. Number 1, use a ruler, draw a line segment for each length. Now, I don't actually have a ruler with me. I was thinking this was a ruler, but this isn't a ruler. This is just a straight edge, because can you see? It doesn't actually have any measurements on it. So I am not really prepared for this. I might have to pause my thing and go find me a ruler. 1 second. All right, guess what, guys? Your math teacher does not have a ruler. All my rulers are at school. Holy cow. So you know what? We're not going to worry about this first section on this activity. Just don't worry about it. If you happen to have a ruler and would like to do that, go for it. Basically, the only purpose here is so that you kind of get a picture in your mind of how long these earthworms are, right? When we start talking about these lengths, you'll have something to refer to say, oh my gosh, that's a really long earthworm, or that's just a little teeny guy, right? So that's really the only purpose there. So let's just dive into part A here. In part A, it says, here are the lengths in millimeters of the 25 earthworms. So here they all are. He measured them and then he made this little table, okay? Complete the table. So now we're doing a frequency table for these 25 earthworms. So let's do this super duper fast. 6. Oh, look at our little ranges here. 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. So keep these in mind as you're doing your frequencies. So 6 goes between 0 and 20. 27 is between 20 and 40. 54 is between 40 and 60. 11 is between 0 and 20. 27 is in here. 59 is in here. 18 is up here. 28, 60, 19, 29, 77, 20, 32, 93, 23, 33, 23, 41, 25, 42, 25 again, 48, 26, and 52. 52 is in there as well. All right, I think we got them all. Let's write our frequencies down. We have 4, 12. I'm going to circle those because they get squishy. 12, 6, 2, and 1. There they are. There's our frequency table. Now, one thing we should probably do to double check our answers on that frequency table, what should all these numbers add up to? If I were to add all these numbers up, what should they add up to? They should add up to our total number of earthworms, right? So 4 and 12 is 16. 16 plus 6 is 22, 23, 24, 25. So we know we have them all. Okay, so there's our frequency table. Guess what's coming up next? Yep, you're right. We need to turn it into a histogram. So let's do this together once again. I'm going to fold this paper down, get rid of that name line. And here we go. I'm going to get my other papers out of my way. Here's our frequency table. Make sure we're on screen here. There we go. Use the grid to make the frequency table. Between 0 and 20, we have 4. So from 0 all the way to 20, we have 4. So these are going to be double wide bars, aren't they? Double wide bars. There's our first bar. We'll fill that guy in. Then from 20 to 40, we have 12. So from 20 all the way to 40, we now have 12. So this is, again, a double wide bar all the way up to 12. Nice straight lines. We'll fill in that bar. Hope you're doing this with me. 40 to 60 will have a frequency of 6. Oh, it's easier to do it sideways here, so I can go straight. And I don't know if I'm always staying in screen. I apologize if I'm not, but I will straighten it up and get it back in screen when I'm done if I wander out. Okay. Now we're to 60 to 80 is 2. So 60 to 80 is 2 tall. And then from 80 to 100 is only 1 tall. All right, so here we go. Let me center it up here. We've got our frequency table and our graph complete. Okay. How did you do? Did you get yours done right? Looking pretty good. Okay, looking at the histogram now. Let's see if we can answer these questions. Based on your histogram, what is the typical length for these 25 earthworms? Well, I think it's pretty obvious to say that it's between 20 and 40 or 20 to 40 millimeters. In fact, we should label this. Length in millimeters of earthworms. Always super important to label. Oh, it even says be sure to label the axes. The axis of the histogram. Glad I noticed that. Actually, I thought of it before I noticed it. Okay, so what is the typical length for these 25 earthworms? Well, it's somewhere in here, isn't it? So I'm going to say between 20 and 40. Millimeters. Okay, and I know that because not only is it the highest bar, but it really kind of is the center of the data, isn't it? So you can explain that. It's the highest bar and the center of the data. Number 4, write 1 or 2 sentences that describe the spread of the data. Do most of the worms have a length that is close to your estimate for the typical, or are they very different in length? Well, I think most of them are very similar, aren't they? Right? We could go back to our actual data and see how similar, right? But I think it's pretty obvious that they are pretty similar because of how high that bar is, right? So again, this is writing in your own words. So I don't want to put words into your mouth here. Write 1 or 2 sentences in your own words that describe the spread of this data, right? There's way more worms that are between 20 and 40 millimeters than there are between 180 and 100, right? This guy is really big and long. Most of them, though, are about this size, okay? And even between 20 and 60, that's the vast majority of the worms, right? Because those are the 2 highest bars. So there's lots of good sentences you can write there, okay? Once you're done with that, we are done with lesson 7. Now I've got my pages all out of order. Oh, we're not quite done with lesson 7. We still have activity 3, don't we? So this is the Are You Ready for More? That is optional. See, that's the page I just threw to the side. So this is optional. I've had a couple of you tell me that you've been doing those, honor students. That's super awesome of you. If you haven't been doing those are just fun. I like these ones, especially in this unit. They're a lot of fun. Again, you get to answer questions about histograms on this one. Okay, so let's move on now to activity 7.3. This one is about basketball and baseball players. It says professional basketball players tend to be taller than professional baseball players. Well, yeah, that kind of makes sense, right? Because in basketball, you're jumping and shooting to that hoop. Baseball players, doesn't really matter how tall you are, right? Here are 2 histograms that show height distributions for 50 male professional baseball players and 50 male professional basketball players. So it's important that they're both male because, of course, females and males are different heights. But so that it's fair to compare, we're doing 50 male baseball and 50 male basketball. That makes sense to me. Number 1, decide which histogram shows the heights of baseball players and which shows the height of basketball players. Now, here comes our histograms. Knowing what we know, knowing that basketball players tend to be taller, which of these histograms do you think is the basketball players? What do you think? My computer is up here above us, and it's kind of in my way, so it's hard for me to tell. What do you think? Well, looking at our label here, these numbers are the height in inches, right? So just to put things into perspective, 5 feet is 60 inches, right? So I am 5'8", right? So 60 inches or 68 inches would be my height, and that's right here, right? Or right here. I'm short, even for baseball players. I don't know. So what do you think here? Looking at these, look how much taller these guys are. There's a lot of players over here in the 80, 82, 84, 86, and there's none here in that range, right? So I'm tempted to say that A are the basketball and B are the baseball. That makes sense to me. Do you guys agree with me on that? And then can you explain why? Well, yeah, I can explain why, because look at how tall these people are compared to these people, right? If basketball tends to be taller, it has to be this one, doesn't it? Okay. Number 2 says to write 2 or 3 sentences that describe the distribution of the heights of the basketball players. So now we're just focusing on the basketball players. Well, the basketball players, what can we say about this distribution? Well, there's 2 peaks here, so most of these players are between what and what? Most of them are between 76 and 82 inches tall. So that's between what? 7 feet and 8 feet tall? Holy crap. Well, that's not true. Between 6 feet and 7 feet. 6 feet is 72 inches, right? Wow, so those are tall guys. So anyway, I'm not going to write these sentences for you. I think you can write those yourself, right? Most of the players are going to be between 76 and 82 inches tall. There's very few. There's only, what, one guy that's a really short guy, and there's only one guy that's super-duper tall. I bet we can guess who that guy is, right? And then number 3 asks the same thing, but this time for baseball. So if we're looking at the baseball players, look how the vast majority of those players are between 72 and 74 inches tall. So they're all right in the 6 foot range, aren't they? Where over here, very few of them were actually in the 6 foot range. Most of them are even taller than that, aren't they? So there's a lot of good sentences we can write for number 3. And now, ladies and gentlemen, we are to the end of our lesson. I would highly recommend you reading this lesson summary because it's a really good one. I was reading it earlier. It's a really good summary of what we've just been talking about. The perks to histograms over dot plots. And there are a lot of them. They really do help understand data in good ways, okay? So that's our summary for lesson 7. We are now ready to do the practice problems in lesson 7 actually, and in lesson 6, right? Don't forget, in lesson 7, you are actually only doing problem 1 and problem 2. Do not worry about problems 3 and 4. Just do problems 1 and 2. So for today's homework assignment, you are only doing 1, 2, 3, 4, 5 problems, okay? So lesson 6, 1, 2, and 3, lesson 7, 1, 2. Go ahead and dive into those. Do your absolute best. Come back ready to check your answers, okay? Don't cheat yourself the chance to try these on your own first so that you can learn from your mistakes if you make any, okay? Awesome. I will see you in just a minute when we will check these answers.
Do your best because you deserve your best.
Let's dive into grading lesson 6 homeworks. Again, we're only going to do problems 1, 2, and 3 today in lesson 6. Let's dive in. In number 1, you are to match the histogram to the dot plot. These are identical data sets. We have to match them up, okay? So let's take a look at histogram A. If we're looking at histogram A, we have 6 that are between 5 and 10, 8 that are between 10 and 15, 8 that are between 15 and 20, etc., etc. Is there something that matches that down here? I'm tempted to say the only one that looks right to me is 3. What do you guys think? I think those shapes and everything about that looks very, very similar. So I'm going to say A is 3. So I'm going to put a 3 here, and I'm going to put an A here, because I don't know which direction you guys went, but either way is fine. Over here to histogram B now. Which one of those dot plots looks like B? Well, the only one that has everything over on this far side like this, the only one that does that is number 1. Does everybody see that? So I think B is 1. So I'm going to match those two up. Histogram C. Here's where it gets a little trickier because this is kind of spread out. But I'm looking at this data and I'm tempted by 5 and I'm tempted by 4. But you know what? 2 looks a lot more like this because it's got that peak. So I'm actually going to jump ahead and do D is 2. I'm going to write the D over there by the 2. So I'm going to call D 2. Let's go back to C though. Do we think C is 5 or do we think C is 4? What do we think? Well, C is more spread out. So which one of these is more spread out? Oh, I think it's going to be 5. Yep, I think 5 is C. How about 4 now? 4 must be E. Do we agree with that? Yeah, look at this. We have, yeah, I think this is going to be it. Yep, E is 4. There we go. Done with number 1. How did you do? Uh-oh. Were you able to see the bottom half of that? Oh, that's okay. At least now we know which ones are which, right? I'm sorry you couldn't see all that. It was almost, well, I guess it wasn't impossible to get it all on one. Oh, maybe I should oh, well. I was going to say maybe I was going to re-video this, but it's not worth it. It's just checking homework, right? So now we know how those match up. I hope you did that right. If not, fix your mistakes. Take a look at those closely and see if you can figure out why those match up the way they do, okay? Let's take a look at number 2 now. Number 2 gives us a histogram and asks us to decide. So it says select all the statements that are true according to this histogram. Let's look at part A. A total of 9 sharks were measured. Well, in order to know our total number of sharks that were measured, that's our frequency, right? So there's 1 shark here, 1 shark here, 4 sharks here, 10 sharks here. Well, that's already more than 9. So that's definitely not true. Total of 50 sharks were measured. Ooh, that sounds more likely. Let's keep going. This is 10. This is 9. This is 10, 4, and 1 again. So 1, 5, 15, 24, 34, 44, 48, 49, 50. Look at that. B is correct. Okay. C, the longest shark that was measured was 10 feet long. I know where they're getting the 10. The 10 is my tallest bar. But is that the longest shark? No, because the lengths in feet are these numbers. So is the longest shark 10 feet long? No, this longest shark is somewhere between 17 feet and 17 and a half feet long. So that is definitely not true. Okay? Part D. Most of the sharks were measured were over 16 feet tall. Or long, tall. They don't stand up. Long. Okay, here's 16. 10, 14, 15 were taller than 16 feet. Was that most of them? No, because this is 19, 29, 33, 34, 35. That's most. Most of them were less than, not more than. So D is out. 2 of the sharks that were measured were less than 14 feet long. Well, here's 14 feet. Do I have 2 that are less than that? Yes, I do. So there's my other correct answer. So the answer to number 2 are B and E. Okay? Moving on to number 3. Oh, number 3 looks fun. We have to draw a histogram. So the first thing we need to do to draw a histogram, and here's where I'm going to use this handy dandy straight edge. We need to draw our axes. We need a frequency vertical axis, and then we need our horizontal, and this is time and minutes axis, isn't it? So let's make our time and minutes axis. Now, to label these, on our frequency side, we need everything from 0, right, to, what's our highest number? 13. So we need to make sure we get to 13 on this line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, we have plenty. 14, 15. Let's label like every other one of these so that I have something to go by. Maybe I'll do up to 16 just because it's even. Okay, so there's my frequency axis. Can we see this down here? Maybe I'm too low once again. Oh my goodness gracious. So there's my frequency axis. Now I need to do my time axis. Now notice, remember histograms are all about these intervals, right? So 4 minutes to 6 minutes. Well, I can't just skip. So let's do from 0 to 2, and then from 2 to 4. And we need to get all the way up to 16, right? 2, 4, 6, 8, 10, 12, 14. Oh, look at that. Perfect. 16. Okay? And they're in groups of 2. 4 to 6, 6 to 8, 8 to 10. So we know we've got those intervals set up right. Okay? But we need to label this time in minutes. Okay? We don't have to label this frequency because on histograms, the vertical axis is always frequency, right? So we don't have to label that, but you certainly could. You could write frequency over there if you wanted to. Okay? All right. So let's start putting our data in there. From 4 to 6 minutes, we had a frequency of 1. So from 4 to 6, that's our first bar. It only has a height of 1. So just up to that little tick mark, see that? And we'll fill that in, okay? From 6 to 8, we have a frequency of 5, so that goes all the way up to here. We kind of have to eyeball these, right? I could pull out my handy dandy straight edge and make sure this is right. There's my 5 line. Yeah, so I was about right, okay? So there's that bar. Then from 8 to 10, my frequency is 13. Wow, I'm gonna have to go all the way up to here. Okay, so from 8 to 10, all the way up to 13, I'm gonna eyeball it as right about there. Look how good my eyeball was. All the way up to there. Okay, and you know what? To make it absolutely obvious, I'm gonna put my frequency numbers right on here. That's a great way to do it, especially when you're drawing them on your own, so that there's no doubt where you meant those to stop, right? So there's that bar. I'm going to kind of fill that in. Okay. From 10 to 12, we have a frequency of 12, so just one less than that other bar next to it. Oh, gosh, my computer once again is in my way. So from 10 to 12 bar goes to there. Okay. From 12 to 14, I have a frequency of 7. So there's my 7 line. So it's going to be up to here. So there's my 12 to 14 bar. Oh, I didn't label these. 12 and 7. Okay. And then my last one, 14 to 16, is 2. So again, to my 2 line over here. See, the farther away it gets, the harder it is to eyeball. But there it is right there, and we'll label that with a 2, so there's no doubt. Okay? There's a great looking histogram if you ask me. How does yours look? Hopefully yours looks just as neat as this one, because that's super important when you're graphing data. You need to be able to see what you've done and need to have it organized, right? All right, so there's our histogram for number 3, and that's the end, okay? So we are done with lesson 6. Let's dive into numbers 1 and 2 only on number 7, on practice problems for lesson 7. All right, lesson 7, number 1. It asks us some questions about these two histograms. It says, these two histograms show the number of text messages sent in 1 week by 2 groups of 100 students. The first histogram summarizes data from 6th grade students. So 6th grade students. And the second histogram summarizes data from 7th grade students. Okay, so that's kind of important to keep in mind. It says, do the two data sets have approximately the same center? If so, explain where the center is located. If not, which one has a greater center? Now, we have to be careful when we do centers on this one, because I was tempted from the first glance to say that this one had a greater center. But then I got thinking, this one is a lot more spread out, which shifts that center differently than you might think it might be, because I'd be tempted to say the center is here. I don't think it is, though, because there's things happening over here. I think it's closer to here. So I'm going to say the center is somewhere in the middle of this bar. Where do you think the center is on this graph? Well, this is a lot squished, more squished, so guess what? I think the center of this graph is right about there too, which means what? I think they actually do have the same center, right around what, 100? Somewhere between 95 and 105? I'm going to say yes. Where is the center located? Around 100, right? Or somewhere between 95 and 105, right? That bar. But we can estimate right around 100 for that one. Okay, so that's part A. Part B, which data set has the greater spread? Oh, we already mentioned this, right? We can tell that this top graph has a wider spread because it goes all the way from 45 all the way up to 155. There's data in every single one of those spots, isn't there? But on this one, the data doesn't even start till 75. And then it ends at 145. See how skinnier that one is? So definitely A, the 6th graders. So you can either call this, well, I don't know if we can call it A because it's not labeled that way. We're going to have to say the 6th graders have the bigger spread, right? And then again, explain that because they go all the way from 45 to 155, while the 7th graders only go from 75 to 145, right? So skinnier spread. So you can explain that in your own words, okay? Part C. Overall, which group of students, the 6th or the 7th grades, sent more text messages? Well, that's really kind of hard to tell on here. What do you think? The fact that our center is the same kind of tells me that maybe they're about the same, right? Isn't that kind of what the center does? Is tell us kind of what the typical student does? And if our centers are the same, then wouldn't that mean that they sent about the same number of texts? I think that's going to be the answer for C, actually. I don't know that it gives us an option of neither, but I'm going to say it. And I'm the teacher, so I'm going to say neither. They're about the same. At about 100 texts, right? That's what we decided earlier, is that their center was at about 100 texts. So I think that's what answers this question, is that because the center is the same, the number of texts that those two grades send are about the same. That makes sense to me. All right. Last one, problem number 2. 40 6th grade students ran 1 mile. Here is a histogram that summarizes their times in minutes. The center of the distribution is approximately 10 minutes. Okay, so let's take a look at this graph here. Oh, there's one more thing we know about it. Okay, it says, so the center of this distribution is about 10 minutes. Okay, so they've already told us that 10 is our center. Okay, so I'm going to make a nice line. That makes sense to me that that would be the center, right? That totally makes sense. That's really a good point in the middle of everything, isn't it? Okay, it says on the blank axis, we have to draw another histogram, and it has to obey 1, 2, 3 rules, right? This third one got bumped to my next page, okay? So this next one has to have a distribution of times for a different group of 40 sixth grade students, okay? So it has to be different than this histogram. It has to look different, but it has to have a center at 10 minutes. So we still want it to center at 10 minutes, just like the other one did. Okay, so basically we want the same frequency on this side as we have on this side, right? We want those to be about the same, okay? The next thing we have to have is less variability than the distribution in this one. So less variability means we actually want this to be skinnier, not more spread out. We actually want it skinnier, which means we want it, everything shoved more towards that center line, don't we? So where I'm going to start, we still have to have 40 people, right? So our frequencies have to add up to 40. So let's write down our frequencies and make sure that we can move things around and make this work. This histogram looks very familiar. Does it look familiar to you guys? Is this the histogram we made? Oh my goodness, look at that. It is. It's the histogram we made in the last activity. Look at that. Pretty awesome. Okay, I knew it looked familiar. Okay, but now we need to make one that has the same center, but looks different, has the same number of frequencies, so they have to add up to 40, right? But it needs to be skinnier. It needs to have fewer bars, in other words. Does that make sense? So let's take this one and get rid of it. But if I take one away on this side, we have to add it to one of these, right? So basically, what I'm thinking to make this skinnier is I want to get rid of that bar and I want to get rid of that bar. Because that'll make it skinnier, won't it? But now I have those 3 that I need to put elsewhere. Well, let's take this 1 and add it to this 5. Should we do that? So if between 6 and 8, I'm going to make this 6 now. So I basically put that guy up in this area, right? So now that bar is a 6. Okay. Now I have 2 more that I need to get rid of, right? So we can add these wherever we want to add them. Should we add one of them to this 13 and make it a 14? One thing we want to make sure of, we want to keep our center. On this side, we had 13, 18, 19. And on this side, we had 19, 20, 21. So that was really close to center, wasn't it? Let's see if we can make it just as close. If I make this 14, that'll be 20, won't it? Oh my gosh, that'll be exactly half. Because 14 plus 6 is 20. Oh my gosh, that's even better. So I think we've made a really good choice by making that 14. All right, but I still have one more I need to add to this one. So we're going to have to make this guy an 8. Oh, we need to do our 12 first. Should we keep the 12 a 12? I say we keep the 12 a 12 and add the other one to this 7 to make it an 8. So let's make this one the 12. Okay, there's our 12. And now this guy is going to be an 8. Okay, so now this side adds up to 20. Look at that. We kept our center at 10. We literally have 20 on this side and 20 on this side, right? I'm going to get rid of those because those don't really belong on our histogram, right? It was just a way to draw it carefully. Our graph is definitely skinnier. It has less, right? Where does it say that? Our less variability, right? It's skinnier. But it still has the same center, and it still has the same total number of data values. So I think we did a great job at changing the histogram, but keeping the rules. right? Awesome. Very, very good job. Now, on this this lesson, practice problems, we do not have to do number 3 and we do not have to do number 4. Not that you can't, actually. These are both review of things we have done in the past. So if you want to review those, go for it. But that's not part of the assignment. You don't have to do that. So ladies and gentlemen, we are done with lesson 6 and 7 combo. Good job on that. You guys are working so hard. We're almost to the end now. We're getting so close, and I really appreciate the hard work. So now it's time to dive into the Check Your Understanding quiz. Go ahead and do that. If you have questions, email me or join me for office hours. You're doing awesome, and I know that will continue because I know you will always
do your best because you deserve your best.